In this video, we'll be looking at applications of solving exponential and logarithmic equations. In most cases, we'll be asked to solve some form of an exponential equation, given that the exponential equations are a little bit more complicated and they're more prominent in real-life applications and how they work. So the first example we're going to look at is the question, how long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest when we compounded it quarterly? So it's important to note that we're looking at a question that either revolves around a equals p e to the rt, or we're looking at a equals p times 1 plus r over n to the power of nt. So it's one of these two cases, and depending on how we compound it tells us how we're actually dealing with this. Now, because it says we're compounded quarterly, first off, we're going to work with that formula. Okay, this one's compounded continuously, and since it's not continually, it's not the one we're working with. So because we're looking at quarterly, we're looking at this one. More importantly, because we're looking at quarterly, n happens. How many times do we compound it in 1 year if we do it quarterly? Well, we're doing it 4 times. Okay, so we're doing it every 3 months, and that's 4 times in total. So the question asks one more time, how long to the nearest tenth of a year? So I'm trying to find out what t is. T is my question mark. Will it take $1,000, that's my initial investment, to grow, my initial investment, to grow to a value of $3,600, that's my end result, that's the amount I'm supposed to end with, at an interest rate of 8%. Remember, the interest rate being 8%, we must convert the 8% to a decimal form, and then again, compounded quarterly, so I already have n equals 4. So we're working with this formula, we're going to plug in all these values, and then we're just going to go ahead and solve it. In this case, I have a equals 3,600. My p is 1,000. My formula is 1 plus my r, 0.08, divided by n, which is going to be 4, all to the power of 4 times t. So with this type of problem, again, the goal is, how do you solve exponential equations? Well, the first thing I would recommend is seeing if we can simplify this base. The second thing I would recommend is getting rid of this 1,000, because again, for us to solve any kind of equation, the normal response is get the thing by itself, except for quadratics. Quadratics is you get it equal to 0. So in this case, I'm going to go ahead and divide by the 1,000, because that 1,000 isn't part of the exponential piece, which will change this thing to 3.6. And I'm going to go ahead and write it as 3.6, because it is the exact decimal value that they've given to me. For this piece over here, 0.08 divided by 4 is actually 0.02, and added to 1 is simply 1.02. And yes, I'm going to write it this way. In most cases, I try to avoid decimals, but in some of these example cases where the decimals are given to you in a very straightforward way, I'm going to go ahead and use the decimals, because I'm going to have to type this stuff into a calculator anyways. It tells me how long, one more time, to the nearest tenth of a year. So I need to emphasize that this thing has to be rounded to 1 decimal. Okay, nearest tenth of a year tells me I have to round it to at least 1 decimal point. So that means I'm just going to go ahead and stick with the decimals that I have as long as they're exact. Again, I didn't round going from here to here. I didn't round going from here to here. So this is perfectly fine still. It's still exact. So then the question is how do I manipulate this exponential equation to get 4t out of the exponent? Well, remember, there's 2 straightforward ways we can do this. The most appropriate way, I think, is simply taking the natural log of both sides. So the natural log of 3.6 and the natural log of 1.02 to the power of 4t, keeping in mind that that 4t is on the exponent of everything in there, which means that that power of 4t can pull down in front of this. So I have the natural log of 3.6 equals to 4t times the natural log of 1.02. Keep in mind that the natural log of 3.6 is a number, the natural log of 1.02 is a number, and therefore I can divide both sides by the natural log of 1.02. I can also divide by that 4 to get t all by itself. In which case, this is the particular value I'm going to have where this cancels out with this cancels out with this, and I'm having t equals this number. I'm going to go ahead and pull my calculator out one more time for this, because again, in most cases when we're solving these particular equations, we're going to want to get this number to be, again, to the nearest tenth. Nearest tenth tells me I'm going to go ahead and use my calculator. So I'm going to have very carefully the natural log of 3.6 ending my parenthesis for that particular value. I'm going to divide that by 4 times. Now I'm going to be very careful when I do this. I'm going to go ahead and divide by 4 times, making sure that I put a parenthesis in there to emphasize that it's all of this divided by 4, because again, the order in which they do the operations of this would be manipulated and wrong if I don't put that parenthesis in there. 1.02 I'm going to end both parentheses there, the log and the denominator, and then when I hit enter, I'm going to get 16.17. 16.17 says it's going to be 16.2. So it's 16.2 what? And again, the question is, how long to the nearest tenth of a year? Well, it's 16.2 years. If we don't put that particular, notation in there, the appropriate unit, then you are going to get this wrong, because it is so important that you actually have the units in every single application problem. But that takes care of how to solve exponential equations if they're in a word problem. Again, the word problem being, how long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest compounded quarterly? That's how you solve that problem. And again, don't forget your units at the end.